Hello everybody. We are doing exercises and therefore we will go on. And let me see, we had, this was supposed to be A3R. Yes. So this was A3. Then this was A4. And this was then supposed to be A5. So then let's move to the general overview A1. Where is it? Snipping. GDP growth. So, what do we have? Explain the 3 different approaches for the calculation of GDP and give the relative size. So, and if we give the relative size, then we also have to know through which number we are dividing. So let's start. So this is then more or less a general summary of what we have done when we talked about GDP. How can we calculate GDP? Our 3 different sides, so to speak, 3 different approaches which we have. You can also flip back in your notes and then you should find the 3 approaches. Yep. Mm-hmm. Yes, but at which sectors we look and what does this production approach means in general? So at which side of an economy, at which side of the market are we looking at when we look at the production, when we take the production approach? The business side, yes, of course, but more conceptually. So to speak, if we are in here, so this is our market, and then we have supply and demand. So which side? Yes, of course. So we are really looking, of course, at the business side, but in this more general, so this represents the supply side. And then, which main sectors do we have? Yeah, yeah, production approach. Idea? Just switch back in your slides and your notes, and then you will find it. So there we had also this longer time series when we looked at it. Yep. Mm-hmm. Private plus public service. Yes. At first, wholesale retail. Yep. And yeah, okay, that's included. Yeah. And then construction. Yep. And one is left. Manufacturing. Mm-hmm. Manufacturing. Yes, and the agricultural sector, this was more or less looking at the histories, and since we started with a circular flow from the historical perspective, and of course, if we go back in time 300-400 years, then the agricultural sector was 90% of the total production of a country, and now I showed you that we have here only 2%. And what are the quantitative proportions of these? You have there also? Hmm? Okay. And then 16, or I take it just around. So you don't have to learn for the exam the exact number. So let's take then here 15% and 5%. And with with respect to which number we calculate these proportions, because it's not relative to GDP, but this hopefully you have also written down, because, or I have shown you. Pardon? Yes, grow value added. Grow. So relative to grow value added. Because this is not exactly the same as GDP, because then you have to take the transfers minus taxes, and then you are coming to the GDP. Okay, then let's take the expenditure approach. Which side of the economy is this then? Yep, demand. And which main components have we looked at? Yep. Mm-hmm. So, and there we have to distinguish between private and government consumption. Yeah, hopefully I have made it. Okay. Private and government consumption. Let's see if this works. Great. Zuck, zuck. And, not that one. And then in general investment. Oops, and external contribution. And here also the relative numbers. trillion, and this is then relative to GDP. Hopefully I have also given you these calculations, maybe on the next slide. So actually, there you could also say that it is roughly 55%. These two were roughly 20% if you take the absolute numbers, and this roughly 5.5%. But this I take in brackets because in the actual situation, this is below, slightly below 50% for 2021. But I nevertheless, I say you can also take these 55% because this was the average number during the last years, and 21 was a quite special year due to the situation of all the payments, the public payments for within the Corona crisis. But well, we have to see. Now, this year and the next year, we also obtain additional public money because of the energy crisis. So I would doubt that 2020, 2022 and 2023, this number will again rise up to 55%. So you can also say this is 50%, and then maybe you say this is 22 or 23 government consumption. Just what I want from you is that you just know, yeah, where the numbers on average are lying. So if I ask the question, how large is the component of private consumption, then I don't want to hear a number like 20% or something. So if you then take the actual number of 2021 and you write down 50%, that is also fine for me. Okay? So because right now we are in a quite special situation economically, so I still take the historical values from the average of the last years, but maybe it is possible that for the next 5 years or 10 years we move into another situation where in the lecture in the next term or in the next year, then I will say, okay, this right now in general 50%. Okay, and this is relative to GDP, and we have the income approach. And what are there the components we are looking at? Oh, did I start the income approach? Yep. Yep. So corporate and investment income, or in general we could say capital income. And the other one? Compensation of employees. And there, in general, we can say that this is labor income. So I think you know from other lectures that in general we take production as a function of capital and labor. And so to speak, we look here at these two main input input components in production. And there, the relative size of which kind of measure we introduced them. This was just in the end of this topic. Yep. Mm-hmm. Yeah. Or one third, two third, whatever you. Yes. And okay, great. And this is relative to national income. And well, maybe the last one, what is GDP in Germany 2021? Roughly. Yep. A little bit more. But this is also okay if I ask you and you say something between 3 and 3.5 or something, then it's okay for me. But now we want more or less the right one. This is then no, not anymore in US dollars because we had almost parity right now. Was a bit less. Yeah. GDP of Germany. Yes, roughly 3.6 trillion euros. So maybe if in other lectures you have the task for some of market analysis about a foreign country or something like this, then I would recommend that more or less just looking at these numbers in France, in the United States, in Brazil or something or somewhere else, and then also on a descriptive way you can start to interpret these numbers for then your specific country, because these are more or less the main components you are looking at a first shot if you look what is going around in a macroeconomic perspective in a country. Okay, then I also had another task for you. In order to summarize what we have done. And this is A2. And the magic square. So this was A1, I write down, okay. So explain in general what is understood by the magic square, the target system of an economy. Name also the different target values with their quantitative size. So at which 4 targets for Germany we have looked at. Also just have a look in your notes. Steady and appropriate economic growth. Next one. Okay. Yo. No unemployment and yep. Mm-hmm. Stability. So and last one. Mm-hmm. Okay, and then let's come to, yeah, these are qualitative aims we have here, and now we want to talk about which aggregates we are looking at. Yeah. Yes. So increase, or let's say not increase, because I think next year we won't have an increase in Germany and in many other countries. So let's take uh, um, growth rate of real GDP and roughly 1 to 3% per annum. And here, of course, we have also to say to add that this is, yeah, a rule of thumb for industrial or developed countries. Because the forecasts for China, for example, are for this year now roughly 3.5%, and this is much too less for this economy because, well, in some regions they are quite developed, but especially if you go to the center of China, it is more or less comparable to African countries in China. So it's a highly diversified country still, and actually to be stable, they need the growth, and we will see how this country will develop further on, because in the last 20 years, more or less, the governments there could just say, well, you see, we perform so well, and we now establish something we can call a middle class, and so we are very successful economically. Definitely, we have to admit that this was a great success in China. But right now, with the zero COVID strategy and what they are doing else, we will see if they have still this economic performance in the next years, and then we will see what the population there will say about the next economic performance in the next years. Okay, then let's go to price level stability. At which numbers do we look here? Yep. Mm-hmm. Yes. So in general, we can say also growth rate of consumer price index, and this is of course inflation. And for the Eurozone, there we have really a definite target, and this was, yeah, yes, so around 2%. Okay, then to be, this is um, and Explicitly, the ECB defines the inflation target with respect to age. And I think I always take the wrong I think it's HICP or HCPI, CIP. Harmonized Index of Consumer Prices. I think it is this way. It could also be the case that it is HCIP, then it would be Harmonized Consumer. No, it should be this one, HICP. Yep. Okay. Let's counterclockwise. We are going to low employment, unemployment, and there. This is of course then measured via unemployment and then relative to the number which could work. So this is then the unemployment rate. And for Germany, roughly 3 to 4%. That they also Germany, then because for other countries you would maybe find other numbers. And my question, why is this target not more in the neighborhood of 0? Because if we take the people who could possibly work in Germany, this are roughly 45 million people. And if we take 3 to 4%, then this is just a number 1 million, 1.5 million people. And this is a quite high number. Why do we talk for Germany that this is identified with full employment? Because then this would still mean that 1 million or more people are out of work. Yep. Yeah, but the amount of these seasonal workers, this is, yeah, I think around 50 to 100,000 people. If you take the cycle, the seasonal cycle, and you are averaging this over the whole year. So this doesn't add up to more than 1 million people. Well, if you are looking in the news in Germany, what we are talking about Ukraine, we are talking economically, okay, of course, about climate and Indonesia, and in these days, we are talking about what in Berlin? In Berlin. In Berlin. So our capital. Yeah, they may start, but in the government process, what we are right now between the opposition and the government, what is right now the struggle between them? Yeah. Yes, of course. Yeah. 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 And what is it, this Bürgergeld? And why I would say this is strongly related to this quantitative target. Yes. So you can sell a main compensation or something like this, yeah? Yeah. And so you are, as a private person, you have the choice. Do I just take this compensation? And this means roughly 1,000 euros per month doing nothing. Or should I work 40 hours for 1,500 euros? This is our social security system in Germany. So we have the choice. And there, if the mesh of the security system is quite narrow, then you could say, well, this is the framework of our country, and then there will be some people who take the choice, why should I? And this is right now the struggle in Berlin, because some people say, well, this compensation is too high, or the incentives to start looking for a work, this is not hard enough within this Bürgergeld, and therefore we will see where we are then in some months. Yep. Yep. Yes. Definitely. Yeah. Yeah. That's possible. Yeah. Yeah. Yes, definitely. And there we will see the next month, the next year, what we will do in Germany about these, yeah, a reform of our compensation system in the employment for unemployment. Okay, and then the last one, external balance. Well, there I also, yeah, talked about it, that this is more from a historical perspective, that you could take maybe the trade balance equals 0 or current account equals 0, but these targets are formulated from a historical perspective, because until 1973 we had a system of fixed exchange rates. And then you could say, well, if I have, maybe as we have it right now in Germany, we here, if we look at this, 5% external contribution. This means our exports in value are roughly 150 trillion euros, billion euros higher than our imports. So a huge capital inflow in our country, and this then would mean, if I have a fixed exchange rate, that my currency has to appreciate. Or the other way around, if my imports are much larger than my exports, then I have pressure on my exchange rate that it depreciates. And if I have fixed exchange rate, then I have to do something about it via the central bank, selling or buying other currencies. But if we have now, we have flexible exchange rates, and then if you have an imbalance in the trade balance or in the current account, then this means that just the currency adjusts, that the exchange rate just adjusting in the one or in the other side. As we have seen it right now, when you take the exchange rate development of the euro versus the US dollar in the last months. Yeah, we came from roughly 1.2, dropping down to 0.9, and right now we are, I think, roughly at parity again. So now we have flexible exchange rates, and then due to imbalances, the exchange rate would adjust. Okay, then let's go back to some calculations. Oop, it's not this one. Copy. Oh. And I think 2 are left. A7. In the country, we have money growth rate of 8%, real GDP growth 3%, velocity of money should be constant, and real interest rates should be -4%. This is a situation which we more or less have in the actual situation, and especially this -4, I mean. Formulate the equation of the quantity theory of money and determine via the total differential the dependence between growth rates and the growth rates, the dependence of the growth rates to each other due to the quantity theory of money. So first of all, just have a look. What was the quantity theory of money? Just go back, maybe 20 or 25 slides in your notes. And there you should find it. Any idea? So this was just prices, actual prices, times what we are producing equals, and how works our economy, that we are always exchanging goods versus money. So the money is the good which keeps our economy going. So then times equals the amount of money, and within a specific period we can of course pay with €1 more than one good. So I buy a pen from you for €2, and then you can take your €2 to buy an apple or something like this. And there, how fast this euro is moving in our economy, this is then called the velocity of money. So this is then price level, production, money, and velocity of money. So, and then in economics, we very, very often interested in growth rates. And there, at a first glance, we have a quite complicated mathematical operation, because we are multiplying here our aggregates. And for this, in order to obtain a dependence of the growth rates of these four variables, we use a mathematical trick, and this is that we take the log of both sides at first. So taking logs, taking the logarithm, then we obtain ln of p times y equals ln of m times v. And this has the nice property that then the complicated multiplication sign splits into a plus sign. So ln of x times y is ln x plus ln y. So we have ln p plus ln y equals ln m plus ln v. And then we take the total differential, and this is something like a general derivative. I think mostly in school also you always take f of x and then f prime of x as a derivative. But of course in economics we have mostly to deal with models where we have more than one variable. And this is then something like a general derivative. So, and this is then written with a differential operator, and the differential operator is written down as a small d. So this is then not a variable, but a differential operator. So d ln p plus d ln y equals d ln m and d ln v. And if you have a look in more advanced economic books, then you will find these calculations with a total differential quite often. So, and this then means that we have to take now always the derivative of our function ln p times the change of the variable itself. So then we can say d ln F is just sorry, here I have to write it another way. If we have again something like f of x, then df of x is just df dx times the change of x, and this is in your one-dimensional calculation just f prime of x. So what we now have to know is what is the derivative of ln p. Or if we have f of x is ln x, what is f prime of x? And again, I would recommend that some derivatives you keep in mind. So the derivative of f of x is x squared, f of x is 3 times x, f of x is 1 over x, f of x is e to the power of lambda times x, so the exponential function and the log function. And then you are more or less done in economics. We are using not many more functions. So what is the derivative of the logarithm? Any idea? You? Yes, it's 1 over x. Well, and then we see here, this is then 1 over p, and then times the change of the variable itself. So dp plus 1 over y. It's always the same because it's always the same kind of function. dy, and then it's 1 over m dm plus 1 over v dv. And the nice thing is now that we have always here the change of the variable divided by the variable itself, and this is nothing else than our growth rates. So this is then always change of the variable over the variable itself, and this we can identify with the growth rate. So then our equation here translates just in the equation that the sum of the growth rates of the left and the right side have to be equal. Well, and then, since this is more or less inflation, the relative change of price level, we can hopefully answer part B if we take our numbers. Because this is then this production approach, so we can identify this with the real GDP growth. This is, of course, growth rate of money, and this is the change in velocity of money. And now just put in the numbers. What do we have then? Inflation, we take quite often the Greek letter pi for inflation. So pi plus, which kind of, what number do we have for real growth rate? So, well, I think it's here 3% or not. So plus 3% equals money growth 8%. And what is the growth rate of the velocity of money? If we look at our task, velocity of money should be constant, then the growth rate of money is, velocity of money is, yeah, 0%, of course. So inflation is then 5%. And C, calculate via the Fisher equation the nominal interest rate in the country. What was the Fisher equation? Qualitatively, this was the dependence between which variables? Have you found it? Yes, but we want to have the exact here. You know, I'm a friend. I'm a friend. I am a friend of exact formulas. So qualitatively, then it's the dependence between real, nominal interest rates and inflation. And the exact equation, did I, hopefully I have written this down also here. 1 plus I over 1 plus pi. And for pi we also already know, and this is then nominal interest rate, real interest rate, well, and then let's solve this for nominal interest rate. So we are multiplying with the inflation factor 1 plus pi and minus I. So we obtain 1 plus r times 1 plus pi minus 1. And inserting, we have minus 4. So 1 plus minus 4% times, and here we have calculated 5% minus 1 is and I'm a lazy guy, so oops, doesn't work. There we are. So I have 1 minus 0.04 and I have 1 plus 0.05 equals this times this minus 1 is 0.8%. 0.8%. And there you also see, well, that here also already, also we are below 10%. You see already here the slight difference, because if you take the approximate formula, then you would obtain 1% and not only 0.8%. Okay, and one last task is left. Eight. Again, one of my favorite topics, the yield curve. A8. So according to the yield curve, short-term interest rates 1-year maturity should be 1% and long-term interest rates 2-year maturity should be 2%. Due to the expectation theory, what is then the short-term expected interest rate in 1 year? So we derived the following dependence, that short-term expected interest rates are approximately long-term interest rates plus the difference between long-term and short-term interest rates. And for this, we just put in our numbers. So we obtain 2% plus 2% minus 1%, and this is 3%. And this was one explanation why interest rates for different maturities could fall apart. But then, this is A. For B, we now want to incorporate the other main explanation why interest rates for different maturities are differing. And this was the liquidity premium theory. Again, was the liquidity theory, premium theory? Well, if I give my money to some other people for 2, 3, 4 years, that he can build a house or something like this. I'm giving my brother 20,000 euro, whatever. Then, well, I'm still the owner of these 20,000 euros. But if next year I want to make a large holiday journey or something like this, and I need 5,000 euros, then I don't have it. And because of this, in general, we assume that the longer I give my money to somebody else, the higher I want to be paid for this, because for this time I don't get my money. And so we can say that within these 2% interest rate for long-term investments, that within these 2% are maybe some liquidity premium. And here in B, we assume that 1.5 percentage points of these 2% are just due to this liquidity premium. And if I assume that I know how large the liquidity premium is, and I still want to apply the argumentation from the expectation theory, then of course I have to subtract this liquidity premium before I can start the calculation of the expectation theory. Okay? Because this has nothing to do with the argumentation of the expectation theory. And therefore, if I do the same calculation due to the expectation theory, then I would have to take expected short-term interest rates would be then long-term interest rates, but minus the liquidity premium. And also in the brackets. So here, long-term interest rates minus liquidity premium minus short-term interest rates. So in order to still apply expectation theory, we have to subtract the liquidity premium from the long-term interest rates. Well, and if we insert this, then of course we obtain 2% minus 1.5 percentage points plus 2% minus 1.5 minus 1 minus 1. And so we have here 0.5 plus 0.5%, and this adds up then to 0. And now we should interpret both results. So in this case, this bracket is larger than 0, and in this case, it is lower than 0. So in A, we have that expected interest, short-term interest rates are lower than short-term interest rates. And what was the interpretation behind this when these are market expectations? So market expectations are that interest rates are rising. And when, in general, will interest rates rise? Well, if we assume also that central banks are steering short-term interest rates, and the expectations are that these are rising, then in general, but also always in general, because if you take the actual situation, we also assume that short-term interest rates are rising, but I don't think that we are, and we think that we are actually in a crisis, but in general, we would think that central banks would rise interest rates in a situation of expansion, or where we more or less in the top in the business cycle. So that expectations are that interest rates are rising. This would mean we expect central banks will increase interest rates, and so in the business cycle we are supposed to be in a phase of expansion. Well, in B, if we say, well, we assume that the liquidity premium within our market is quite high with 1.5 percentage points. Then we see short-term interest rates are higher. Sorry, this is just the other way around, of course. This has to be greater, of course, and here also. So that short-term interest rates are falling. And then, of course, we have the opposite argumentation. Compared to A, and this was then result that we are in the downturn or in the crisis in the business cycle. And this was then in general the argumentation that the yield curve can be interpreted as an expectation indicator where we are in the business cycle. And for these of you which had entered the talk of your grant about investment, then in general this is the thing you have to know, where we are in the business cycle. Should I buy stocks or should I buy more secure investments? Well, and then I think it was quite late yesterday, but I loaded you up a new task. I've written too much, I see here. And where do I find it? So. So we have another 10 minutes. So after all the theory, we want to do some really relevant. I think it was you just asked the question, because I mentioned if we go in history, then we find more or less the inverse, the inversion of the yield curve in every large crisis in history. And so let's look if this is really true. And I also found that it is really interesting to look at these if we compare the situation of Germany and the United States in the development of the yield curve. Okay, so, and here are the links where you can find the data. This is also always, quite interesting that you know where do I get my data. So let's go to the Fed Reserve and Treasury. What did I want? 1 year USA. Hopefully this works. Market yield. Yes. So this is then, we can this interpret as the short-term interest rate in the United States. Clicking on this, and then we want to have a long time series. So let's take here the 1960s. Oh, not 22. Again. So we have here the short-term interest rates, the development in the United States from 1962 until today. Let's download the data. Oops. And lectures. Macro lecture. This is short term. Then let's take the 5-year. Download data. This is then long term. And what else do we need? Real GDP growth. USA. Potential? No. Well, I would also recommend, this is Fred Excel add-in. This if you in the future want to download especially data from the United States, then you have here, I put this also on the slide, Fred Excel add-in. Then you can just install this and then you can easily download directly in Excel. So where is it? Here. And then we take US data, national income, real growth, domestic product, and frequency of aggregation quarterly, and get the data. And now we have from 1974 our growth rate, our GDP, and oh, I think I can also data manipulation, percentage change. Get the data, and then we have already what we want to look at, because what we want to do now, we want to look at when did we have an inversion of the yield curve, and we want to look when did we have a crisis. So let's take this data then from 1962, or I just put in the other data in this file. And the 1 year data, where is it? There. This is 1.3 and this is 1.2. So then I have to put it in here. This was DSG1. So, and in order to know when did we have an inversion, we just calculate long term minus short term. Okay? So this would be then 5 minus 1, so to speak. Oh, up. 5 minus 1 equals this minus this. This takes very long. So how did I can copy this? I think this is possible in this way. So, oh, now I have to go back again to short term. So, and then, of course, this is very much data, but we have to identify when are this number is negative. Okay? So, and then you can put in when this number is lower than 0. This number I want to have, so I put the number itself, so the cell itself, and otherwise I write just a 0. And if I take this, oh, this is too long here. How can I move downwards here? Where are we? 78. How can I get fast downwards here? Let me try this. No, it doesn't work. No, it won't take that much time. I don't know why it doesn't function. Oh, this is only 62, so this takes too long. No, sorry. Why is he not jumping down there? This works, and here. Now it's crashing my program. Now I'm back again here. So let's try fix this. Again, I try this one. So this minus this. This is too long again. I don't know. $94 or $7.99. So hopefully now it works. No, I'm really puzzled why it doesn't work. Sorry. Um, I think I have to look. I don't know why, because it would take too much time if I have to scroll down here. And therefore, yeah. But let me say what you should do now is, so you identify here all the numbers, and then you can just plot where I have where I have an inversion of of the yield curve, and then you can take here the growth rates, and there technically we speak if you have 2 times negative growth rates, so 2 quarters in a row, we identify this as a crisis. So you try to identify every period when you had 2 times 2 quarters with negative growth rates, and then you just lay these 2 diagrams. You put them together, and then you see more or less you have almost 100% correlation, because this was your question. And if you do this also for German data and for the United States data, then you will find something really interesting in the actual situation which we have here. But this we will have a look at next week, and maybe you'll find it by yourself. Try it. Okay, thank you. Hallo, Bernhard Köster. Mussten Sie kurz in der Veranstaltung machen. Genau. Ja.